Right, good morning, boys and girls. Good morning, colleagues. My name is Mr. Mpahama. You are welcome to this session. Today we are going to look at the graph of a cubic function. Of course, you agree with me that there is a lot of marks on this topic, especially calculus, that you must make sure that you collect. Right, let us start now because we don't have enough time today, only 1 hour, 30 minutes. Looking at these functions here. Remember now, for all functions, it's very important that you know how to sketch, how to determine the equation, as well as the interpretations. Those are very, very important. Right. Let us now start now with the graph of a cubic functions. Let us see now, what is it that is important here? First of all, now you look at this one now. We have the standard form. We have the standard form. Of course, the standard form of a cubic function is f at x is equals to ax to the power of 3 plus bx squared plus cx plus d. Of course, that is the standard form. And then now these are the shapes of the graph. If a is greater than 0, then if the value of a there is positive, now the shape of the graph now will look like this one here. It means the graph will increase first. You can see here now, the graph increase. We have the turning points, and now the first turning points that will come across there will be the maximum turning points, and thereafter the graph decrease and increase after. And then immediately when it increases, now we are going to have the minimum turning points. That's only when a is greater than 0. Of course, also you'll find that sometimes it is less than 0. If a is less than 0, then the graph, look at the graph, it decreases first. Now, if the graph decreases and then increase, of course, the first turning point will be what? Will be the minimum turning point. Of course, thereafter, now you are going to have the maximum turning points. Of course, the shape, you need to remember the shape. If a is greater than 0, what's going to happen? The function increase and decrease. The first turning point will be the maximum. Then if a is less than 0, the function decrease first. Thereafter, now we have the minimum turning point. Right, this is the shape of the cubic function. Of course, now let us look at the procedure for sketching the graph of a cubic function, which is very, very important, boys and girls. Of course, the first thing that you know, for all functions, x and the y-intercept are very, very important. But what's important is, what is it that you must do when you find the y-intercept? Of course, you let x to be 0. X must be 0 when you determine the y-intercept. And of course, for x-intercept here as well, you must also let y to be 0. F at x, g at x, h at x must be 0. That is number 2. And of course, now this one is very important. Now remember here now we'll be dealing now with what? With the cubic function now. Of course, first of all, when you solve for x, when you find the x-intercept here, what you must do first is you must find the factor of f at x. You must find the factor of f at x, of course, by finding the common factor. Always remember we say the same thing with the quadratic equation, finding the common factor first, or if possible, by grouping the terms together. There are 4 terms. Now on those 2, if you group them together, now sometimes you are able to take out a common factor, right? Of course, now, if that one doesn't work, of course, you'll have to use a factor theorem. You remember the factor theorem? Yes, you must find that value that when you substitute it in the original equation there, it must give you what? It must give you a 0. Then we'll see that now is our x plus 1 or x minus 2 is our factor. That is a factor theorem. Right, thereafter, now number 3 there, we need to have what? The turning points. Boys and girls, this part here is very, very important. Very, very important. How do we determine the turning points of a cubic functions? Don't say x is equals to minus b over 2a. That one is for what? That one is for a quadratic functions. That one is a quadratic function. Okay, here what you must do first, you find the derivative. You find f prime of x, and then you let f prime of x to be 0. It means when you are finding the turning points of the cubic function, of course, you need to have the derivative, f prime of x, then you let f prime of x to be what? You let f prime of x to be 0, and now you solve for x. Right, we are still busy finding the turning points here. Of course, now once you have solved for x, now it means now the values of x that you obtained there, you will substitute those x values into the original equations to find the y coordinate of the the y coordinate of the turning point. It means from this one here, we will have the x coordinate of the turning point. Now, once you have the x coordinate of the turning point, you substitute x now in the original equation to find the corresponding y value. Right. Of course, boys and girls, now from these two, now you will have the coordinates of the turning points. Of course, we can state the nature of the turning points. Is this the maximum turning points? Is this the minimum turning points? Well, remember now, if A is positive, now you'll see which one will represent the maximum and which one will represent the minimum. The same apply if A is less than 0, then you also see, because the function will start decreasing and increase, this side the function will increase and decrease. Okay, right from here now you can now be able to do what? You can now be able to draw now a smooth, you can now be able to draw a smooth curve. Of course, this is what you need when you sketch what? When you sketch a cubic function. So of course, boys and girls, I think before we find the equation now, I want us to look at this one where we sketch the cubic functions. Right. Now, how to find a point of inflection, of course, it's also very important here. You find what? You find the second derivative, second prime x. Can you see that one? You find second prime x, and now you equate it to 0. Thereafter, then you solve for x. You find the second derivative, you equate the second derivative to be 0, and then you solve for x. Good. Now, the next one also, you can also use x is equals to minus b over 2a. Remember now, this one, it means now you'll only going to apply this one in our first derivative. Second derivative, remember now we will be having from the standard form here. When I find the derivative, remember now it will be f prime of x is equals to what? 3ax squared plus 2bx plus c. Then it means this formula here, the one of x is equals to minus b over 2a, we are going to use it in our derivative, 3ax squared plus 2bx plus c. Then it means once you have the first derivative, once you have the x coordinates of the turning points, now you can use the derivative now to solve for x value of the point of the inflection. That is why we say use y is equals to f prime of x. Right. Now, sometimes you can also take the x coordinate of the turning point. You can also take the x coordinate of the turning point or the x-intercept of the parabola, right? Now you just add the 2, you divide it with 2. Then you'll get the x coordinate of the point of the inflection. Of course, thereafter, now what is it that you're going to do? Then you substitute the x value into the original to find the y value. Right, boys and girls, now let us now look at the first part now where we do what? Where we sketch this one. Of course, I'm going to take one of the past paper. Then we solve to see now, we try to apply whatever that I said earlier on with regard to the procedures for sketching the graph of the cubic function. Of course, let us look at this one together here. It says now question 1, that is November 2009. We are given that f at x is equals to minus x to the power of 3 plus x squared plus 8x minus 12. That is f at x is equals to minus x to the power of 3 plus x squared plus 8x minus 12. Of course, boys and girls, the first question there, they are saying we must calculate the x-intercept of the graph of f. We must calculate the x-intercept of the graph of f. Boys and girls, now I told you here, what is it that you must do when you do what? When you determine the y-intercept. Remember we said for you to find the x-intercept, of course you let f prime of x to be 0. Now you find the factors of f by finding the common factor first. If there's no common factor, you try first by grouping. And then if it doesn't work, then you use what? You use the factor theorem. Of course, it's a 5 marks question. Boys and girls, can I start first saying that, can you work on this problem so that at least I just see if you understand the procedures for sketching the graph of the cubic functions for about 4 minutes. Then immediately after this one, then we can do it together.